In question 1, you need to forecast the data for ratio to credit percent or CP. And the question has asked you forecast that series for year 8 using naive model. Let's first briefly talk about naive model. The simplest of all forecasting methods is to assume that the next period will be identical to the present. The simplest naive forecasting model, in which the forecast value is equal to the previous period value, can be described here in this algebraic form, where here ft or f sub t represents the forecast value for time period t, and a sub t minus 1 represents the observed value one period earlier, t minus 1. So now we need to use this algebraic form to forecast the CP. So we cannot forecast year 1. That means our forecast is going to start with year 2. In year 2, the forecast will be the actual value or the observed value in the previous year, which is 15.7. And in year 3 is going to be the actual value in year 2. And then you continue like that. You just need to copy paste the numbers here. When you come year 8, you can forecast year 8 because you have the actual data for year 7. So that's all you need to do for 1A. In question 1B, you need to plot the actual and forecast values of the series for years 1 through 8. And there's an explanation in the question. It says that you will not have an actual value for year 8 or a forecast value for year 1. You need to click on Insert, and then you're going to come here for a line graph. Choose any of them. You can select the data. To select, you right click on your mouse. So here, I don't want question 1B. I'm going to edit that, or you can just delete it. I'm going to choose the CP, the series name, and then the data that I need to feed here is going to start with year 1 until year 8. Just be careful because we have a forecast value for year 8. You cannot ignore year 8 although you don't have an actual data. And then click OK. And then you need to now forecast. You're not done here. You are going to first title your series. And then you are going to select the data. And now you complete and you're going to click OK. And one additional things I want you to do that, please add a title to your chart. You can just put it on the above, and saying that you can just come here, click and say CP, actual, and forecast. You can title anything you want that can identify your graph. And then if you please add legends so that we know what are the data titles. That completes question 1B. In question 1C, you need to calculate the root mean squared error for your forecast for years 2 through 7. The first thing is you need to know what is an error. The error is the difference between actual and forecast. And as you realize, the smaller the error, the better the forecast is. Given this, you cannot calculate error for year 1 because you do not have a forecast data. Given that, you cannot even write it here, error as 0. Error 0 means you forecast perfect. And then you start with year 2 because you have both actual and the forecast, and you continue until year 6. Again, be careful. You cannot write 0 here because you cannot calculate error. To calculate error, you need both actual and forecast, which we have only forecast. So we have errors of 6 years. If that's clear, let's try to understand the algebraic form of root mean square error. So if you read this algebraic form, the first step, take the difference between actual and forecast. It's not only 1 year, but you should do it for all years you have data for both actual and forecast. So here, as you see, we calculate the error term. You can see the formula here. It's actual minus forecast. And the second step is, okay, you see the here, power of 2. Squared error, again, for each year you have data, which we can do by using the formula written here. And then you will do it for 6 years. And the next step in the algebraic form says that sum all these squared errors from 1 to n. And here is number of observations that you have error. As you see here, you have 6 years of error. So you need to sum all these errors and then divide by n. That means you sum and divide by number of observations, you will get mean squared error. Take the average function, but be careful again. I'm taking average of squared errors for 6 years because I calculated 6 years of error, not 7 or 8 years. And then the last step is taking the square root of, that means That completes question 1.